Hi, science friends. So this video is going to explain the lab Magnet and Compass Interactive Lab. So if you go to November 13th and you go to under your assignments, you're going to click on the lab activity. So first what you're going to do, it says, ever wonder how a compass worked? To point you to the Arctic or to point you north or to help you with direction. And if you ever did wonder, we're going to talk more about that. And if you didn't wonder, well, you're going to find out. So first, number one, what you're going to do is you're going to watch the two videos on this website. You're going to click this where it says website. And the videos are called magnets. And then another one is called magnetic fields. So if you click on that activity, if this pops up, then all you do is click to enable Flash Player. If you're unable to do that, please make sure you hit allow. And if you're not able to do that, then you have to unblock the pop-up.
Loading done. Magnetic poles.
All right, so now you're going to hit start.
Click a picture to watch the movie.
So first you're going to click here, and it's going to load the video. And then you're going to click the second one, and it'll load that
Magnetic
video.
fields at.
Okay, and that's it. I'm going to hit pause as soon as actually I'm going to close out of that.
Let's look at how magnets.
All right, so now after you do that, you're going to go to this website. It's an interactive website about bar magnets, and you're going to follow the directions here. So you're going to explore how the compass and magnet interact. Then you're going to click Show Planet Earth, and I'll show you where that is on the right side of the page. You're going to vary the magnetic strength of the magnet. You're going to take a look at where north and south on the magnet are versus on the Earth. And then you could, play around with all the other options, and then you have 3 questions to answer. Okay, so let's go to that site. It may take a minute to load. So here is our bar magnet. You can move that around. And then here is our compass. And the magnetic field is all of this around it. And this magnetic field, if you look at it, they all look like little compasses. It's just showing you where the field is directed around this bar magnet. So if you take a look at the compass, red is north. And as we learned from our pair deck, opposites attract with magnets. So this is the south part of the compass. It's pointing towards the north because they're attracted to each other. North and north repel. And the same thing here. The north part of the compass is pointing to the south. Okay, and you can move your compass around to see how it moves as you move it around the bar magnet. You can move your bar magnet around to see how the magnetic field changes. Take note at what side is pointing to the south and what side is pointing to the north, and what happens as you move the bar magnet around. Okay, the field is following it, and when the field goes through the magnet, it comes out the south side and goes into the north side, like in a circular motion. Okay, so let's take a look at the questions on the worksheet. Number 1, it says, how does the magnetic field move as you move the bar magnet around? So take a look at the magnetic field. So what side is always pointing towards the north side of the bar? What side is always pointing towards the south side of the bar? Okay. Now you could also, as you're moving your compass around, think, well, wait a minute, the compass always is supposed to point north. That's true, except when you're next to a really strong magnet. And if you watch season 3 of Stranger Things, you know that law about magnetism in that episode or in that season. So this compass is next to a magnet, so it's going to respond based on that magnet. Okay, if you're not next to a really strong magnet, then the next strongest one is going to be our Earth's natural magnetic field. But here, we're really close to that magnet. All right, the next question says, increase and decrease magnetic field strength. How does this affect the magnetic field around the bar magnet? So I'm going to move our compass over. Come here, compass. And up here on the right side, it says the strength is 75%. Well, what if we moved our strength like down to 10%? Okay. So I know it got lighter, but let's take a look at this magnet. I'm sorry, the compass. It doesn't really respond as quickly. It's kind of like a lazy compass, almost in a way. Its north is still going to point to the south, right? They're still going to be attracted to each other in that way, but it doesn't really respond very quickly. What happens if we move to that field strength all the way up? Wow, love is like moving around really fast, really responding to that really strong magnet. So you can have some magnets will lose their polarity. And how does this compass react? How does the field around it react when you increase and decrease the magnet strength? Okay, the third question here, it says, click the Show Planet Earth option. Describe how the Earth's magnetic field relates to a bar magnet. So we're going to click here, Show Magnetic Field, and Show Planet Earth. Okay, so now remember from our pair deck that we talked about geographic north and magnetic north. So take a look at the bar magnet, and wait a minute, this is geographic north, but this says south. So remember, I kind of blew your mind the other day, that geographic north, in order to get a compass to point north, it's attracted, remember, to the north is attracted to south, and south is attracted to north. So to get this magnet to point north, okay, this is actually magnetic south. That's how we get our magnets to point to the geographic north. And then geographic south is actually magnetic north. And that's how our compasses work. And these fields will flip every so many thousands of years. Okay, so just keep that in mind. So right here, we're on Earth. We want to go north. Our magnet is going to only point north because it's pointing to magnetic south. But now you're going to explain in this question, how is Earth or Earth's magnetic field like a bar magnet? So take a look at this picture and let's talk about what similarities they have. Okay. So you can always also go to your textbook. We have information about that in there. Think back to our peer deck, and you can do some Google searching as well. Okay, and after you're finished with this lab, please remember to turn it in to get credit. This is for the the second marking period. Will count towards that lab grade. Okay, I hope you had fun with this lab, and feel free to ask me questions if you need help. Bye.